Good evening, everyone. Am I audible and visible? Confirm the audio and video once. So I can see there are 29 viewers already. Karthik, hi. Blue Heat. On YouTube, the names are not very familiar. Hey, Ayush, yeah. I just started that. So in our regular classes, we have completed numbers. And I thought of having a complete revision of whatever is important for the IPMAT exam. Good evening, everyone. Okay, so let's start with a basic question. Okay, I want you guys to feel numbers. Like you feel some kind of music, some kind of painting, art. Same way, let's feel the numbers. Here we have a question which says, I'll just write it here. So as you can see, we have this number 1, A, B, C, D, 7. It's a 6-digit number and I need to multiply it by 3. When I do it, what is happening? The new number is formed of same digits. The only difference is that all the digits have shifted one place towards the left. So D goes to C, C goes to B, B goes to A goes to 1. And 1, having nothing here, goes there and 7 comes to D's place. So this is what has happened. We need to find the value of A plus B plus C plus D. Let's try it out. How many of you can do it? Let's try this. You have 2 minutes to solve this question. Interesting, huh? The resultant is form of same digits. Through it will be an hour and a half. Probably it can go up to 2 hours. At max 2 hours. Who is going to solve it? Okay, see. The first one is easy, right? 3 sevens are 21, so 1 is here, and 2 would be carried forward, right? That makes sense. After that, 3 is multiplied by D, and when 2 is added to the product, we get 7 as the units place. Okay, so 3D plus 2 ends at 7. How is that possible? If 3D ends at 5, and that's possible if and only if D is equal to 5. So if I replace D with 5, 3 5s are 15, plus 2 is 17, 7 comes here, 1 is carried forward. And because D is 5 now, so let's replace this D by 5 as well. 3 into C plus 1 ends at 5. How is that possible? 3 multiplied by C is something, can be a 1-digit number, can be a 2-digit number. When 1 is added to it, we get 5 in the end, which means 3C should end at 4. That's possible if and only if C is 8, because 3 8s are 24, plus 1 is 25, 5 comes here, and 2 goes to carry forward, and C is 8, let's place 8 over here. Alright. So 3 multiplied by b plus 2 ends at 8, which means 3b should be ending at 6. It's possible only if b is 2. 3 2s are 6 plus 2 is 8. There's no carry forward over there. This 2 will come here. 3 into something ends at 2. That means a has to be 4. 3 4s are 12. 2 comes here. 1 is carried forward. 3 1s are 3 plus 1 is 4. And that is satisfied. A is 4. So we got the values of A, B, and C and D. Okay? Which means the value of this sum will be 4 plus 2 plus 8 plus 5. That is 19. Is that clear, everyone? Beautiful question, isn't it? So, now I want to show you something which is really exciting. Okay. The charm of number 7. The charm of number 7. If I write 1 by 7, if I calculate 1 by 7, I'll get 0.142857. This keeps on repeating. Just put a bar over it. What does that mean? That is 142857, 142857, and so on. It keeps on repeating. So I want to show you a pattern, a very beautiful pattern. I'm writing these numbers in a clockwise fashion. 1 goes here, 4, 2, 8, 5, and 7. So I can say that the cycle is clockwise, starts at 1 and ends at 7. That is how the cycle goes. All right. By the way, if I want to calculate 2 by 7, and you would ask me, why are we calculating that? The reason is simple, because there can be some questions in which you will have to find the percentage value of, let's say, something increases from 70 to 90, then what's the percentage increase? 70 to 90. Increase of 20 on 70 is 2 on 7. So I want to calculate it quickly. Now, listen to me carefully. If I divide 2 by 7 normally, if I put a point here, this becomes 20. 7 2s are 14, 7 3s are 21. Okay, 2 comes here. So basically this can be done mentally. Like in mind you can do it. 7 2s are 14. So after point, the first digit which should come here is 2. Now in this cycle, where do we have 2? 2 is here. Clockwise, after 2 we have 8, 5, 7 and 1 and 4. So this will be our answer. Isn't this interesting? Numbers, they play like it. 3 by 7, let's calculate that. 0 point, what should come at first? We put a point, 30, 3 becomes 30, 7 4s are 28. 4 is the first digit. After that, 2, 8, 5, 7 and 1. This keeps on repeating, isn't it? We just have to find the first digit and our life is sorted. This 40, 7 5s are 35, 7 6 are 42. Should be starting with 5. After 5 we have 7, 1, 4, 2, 8. Similarly, I can calculate the value of 5 by 7 and 6 by 7 as well. Okay, so this is a pattern but it's very useful. And now by looking at this pattern, can we find a similarity? Yeah, Ayush, this is a great method. Now, can we find a similarity between the previous question and this? See, here, the original question, in the original question, the first number, the first digit was 1, last was 7, overall it had 6 digits. And after that, the same digits are repeating, it's just one place towards the left. So whenever you have something like this, if a 6-digit number is getting multiplied by something, and if the product has the same digits, then it would be a property of number 7 that is going to be there. So let us try to make the analogy. We have 1 here, 7 here, looks like this, 1 here, 7 here, 1 by 7. If I multiply this by 3, I'll get 3 by 7, which is 4 here and 1 here. Look at this, 4 and 1. It is happening. So a lot of questions can be made just by using this. So if you have studied from me and something like this comes up, you know this technique and you can solve anything. So this question is solvable, like in just 5 seconds you can solve it. And Even if you want to calculate the percentage value of something which is divided by 7, you can be able to find that quickly. Swarit, that's a pattern. It's a pattern and it is applicable only when you divide something by 7. By the way, you want to see something exciting? Tell me, what is 21 by 7? It is 3. No need of much calculation. If I make it 22 by 7, what is this? 7 3 is 21 and now 1 is left. So this thing will repeat itself. And now all of you know, you must have seen this ratio. This happens to be most famous ratio known to mankind. It's known as pi. So that is why we consider, see, the value of pi is not known yet. But the first 3 digits are definitely 3.14. So in your schools, you must have seen the questions where it says, take pi as 22 by 7 or 3.14. So that is the reason. That is the reason why pi is approximately equal to 22 by 7. Blue hat, yeah, it will be on this channel. It will be recorded. Interesting, isn't it? See, यही कारण है कि लोग बोलते हैं 22/7 पाई की वैल्यू होती है, बट एग्जैक्टली सेम नहीं होती. The pi values, it has got so many digits, but the first 3 digits are same here. That is why we consider 22/7 to be the approximate equivalent of pi. Pi is an irrational number, but 22/7 looks like a rational number. Interesting, yeah. Okay, so let us go to the next questions. These kind of questions we can solve. It is a very common question which is asked. We want to rationalize this. It is 0.123 and 2 3 2 3 are repeating. So let's put a bar on 2 3. That's it. 1 is not repeating. Okay. So whenever you have something like this, what has to be done to solve this question? Let me show you something simple. 0.22222. This will be equal to 2 by 9. So the number of digits beneath the bar, if we have one digit beneath the bar, there will be 1 9. Let's say we have 2 digits beneath the bar, we will have 2 9s. Let's say we have 3 digits beneath the bar, we will have 3 9s. Let's say we have something like this, 0.01. Bar is only on 1, but not on 0. Here, the bar is only on 1 digit, so we will have 1 by 9. But after decimal, we have 1 extra digit, that will be number of zeros. Now, looking at this, is that clear? 1 by 90. Because after a point, there is an extra 0, but it's not under the bar. And if you have something like this, 0.12, bar is only on 2. So 12 upon 9, because bar beneath the bar, we have only 1 digit. And after decimal point, there is 1 digit which has got no bar. So that will be equal to number of zeros. Once we have done that, just subtract the digit which is not under the bar. And we get the answer, 11 by 90. Let's do the same thing over here. Let's write 1 2 3. How many digits come under the bar? 2 digits. There will be 2 9s. And how many digits do not come under the bar? Only 1 digit, that is 1. So 1 0 and subtract whatever doesn't come under the bar. So answer is 122 upon 990. That is how you can solve it quickly. You can, of course, try to cancel it out. This will be the exact answer. Clear, everyone? So if it is clear, tell me the answer to this question. Everyone, be quick. Okay, so here we have 0.12 bar is only on 3. So 123 minus 12. After that, bar is only on 1. We'll have only 19 and 2 don't have bars. We'll have 2 zeros. So all we get is 111 upon 900. This can be divided by 3. 37 upon 300 will be the correct answer. Let's see how many would do the same. Perfect. Very good. Let's talk about prime numbers. So prime numbers are those which have exactly two distinct factors. So you must have read in your books, it says prime numbers have those numbers which have factors as 1 and itself. Now, by that definition, that's not a correct definition. Correct this one. Exactly two distinct factors. Of course, 1 will be a factor of all the numbers and every number will be a factor of its own. So, if we have prime number, let's represent it by p. So, 1 and p will be the only factors, there will be nothing else. Alright, there is one thing. The other pointers which are important for prime numbers are that all prime numbers which are greater than 3 can be represented as 6k plus minus 1, but reverse is not true. The reverse is not true. So I am saying all the prime numbers greater than 3 can be represented as in this form, but all the numbers which can be represented in this form are not necessarily primes. Let's try to check it out. So if I put k is equal to 1, then this value will be 6 into 1 minus 1 and plus 1, which means 5 and 7. Okay, these are primes. Put k as 2, 6 2s are 12, minus 1 is 11, plus 1 is 13. Perfect. K as 3, I get 17, 19, both are prime. So far so good. If I put k is equal to 4, I'll get 23 and 25. 23 is prime but 25 is not. So basically all the primes can be represented in this form, but reverse is not true. Okay, cool. Well, this is what we know. Now all the numbers which are not prime, they are composite numbers and they are made by various combinations of prime. For example, 30. So 30 is a number which is made by 2 raised to power 1, 3 raised to power 1 and 5 raised to power 1. This is 30. So the moment I wrote it in this way, this is known as prime factorized form. For example, I need to factorize 45. This will be 3 raised to power 2 multiplied by 5 raised to power 1. Let's say I want to write 100. This 2 raised to power 2 multiplied by 5 raised to power 2 and so on. Right? It is clear to all of you? That is how you factorize. So, all I can say is, if a number can be factorized as p to the power a multiplied by q to the power b multiplied by r to the power c and so on, where p, q, r, etc. are primes and a, b, c, etc. are natural numbers, then the number of factors, NOF is number of factors of n, will be equal to a plus 1 multiplied by b plus 1 multiplied by c plus 1 and so on. So basically you just need to add 1 to the powers and multiply them all to get the number of factors. Is that clear, everyone? So let's try to find the number of factors of 45. So 45, here a is 2 and b is 1. So the answer is 2 plus 1 multiplied by 1 plus 1, which makes it 3 into 2, that is 6. So we don't care about which prime are being used. We care about only the powers that are being used. Perfect. Understood, everyone? I'll wait for a minute so that you note this down. All right. Sum of factors will be given by p to the power a plus 1 minus 1 minus 1. This will be there. All right. Upon p minus 1 multiplied by q to the power b plus 1 minus 1 upon q minus 1 and so on. These are sum of factors. And we also need to find the product of factors. In some cases, product of factors of n will be equal to n raised to power the number of factors upon 2. Number of factors is found by using this formula. So 1, 2 and 3. These three things are important here. Just note this down. How many of you are not my students? Done, everyone? Cool. So let us try to find the answer to this question. You have 2 minutes for this. Let's do it. All right. Who have got the answers? More than one. That's what I think. Okay, let's check it out. So, to solve this question, first of all, multiple ways to do it. But what if, as I said, all the prime numbers can be represented in this form, 6k plus minus 1, which means the value of p square will be 36k square plus minus 12k plus 1, isn't it? And we need to find p square minus 1. So p square minus 1 will be 36k square plus minus 12k only, which also means I can take 12k common. I'll be left with 3k plus minus 1. That is what we have. All right. So, tell me something. This 12k would always be a multiple of 4. Can I say that? Whatever k is, 12 तो multiple of 4 तो है, ये confirm है, isn't it? If k is 1, then also multiple of 4. If k is 2, then becomes multiple of 12 into 24. That is how it goes. Okay. I can also say this 12k whole is a multiple of 12. Right? That can be done. And 3k plus minus 1, if we talk about this value, 3k plus minus 1. So if I put k as 1, 3 into 1 minus 1 will be 2. Okay. If I put k as 2, 3 into 2, 6, plus 1 is 8, minus 1 is 5. So basically, what is happening over here? This thing, 3k, if k is odd, there'll be other values. If k is even, we have different values. So if k is even, let's say k is even. If k is even, then this 12 into an even number would be a multiple of 24 for sure. So this whole becomes multiple of 24. That is for sure. And if k is odd, so if I put, let's say I put 1, 12 into 1, and here I have 3 into 1, 3 plus 1 is 4, minus 1 is 2. Still I'll get 2 or 4, which means even if k is odd, then also this will be multiple of 24. Yes or no? That is there. And if this becomes difficult for you to understand, we can do it in one more way. And that is, let us take the numbers one by one. Greater than 3, prime greater than 3. So let's take p as 5. If I take p as 5, then 5 square minus 1 will be 24. If I take p as 7, then 7 square minus 1 will be 48. If I take p as 11, then 11 square minus 1 is 120. All these numbers are multiples of 24. So if you say it has to be more than 1, is it right? Actually, it is right, because all the multiples of 24 would also be multiples of 6. That means we'll go with more than one of the above. Is that clear? Clear, everyone? तो मेरे ख्याल से बहुत लोगों ने ऐसे ही किया होगा. And this is a better approach because we have to do it quickly. 24 का तो होगा ही होगा, 48 का ज़रूरी नहीं हो, है ना? 48 का ये है, बट ये दोनों नहीं है. बट 6 और 24 का तो हमेशा होगा. 24 itself is a multiple of 6. So more than one of the above. Perfect. You got it? Right. ठीक है. Let's do next one. How many numbers n that lie in the range from 2 to 100 is factorial n minus 1 divisible by n? So factorial n minus 1 should be completely divisible by n, which means factorial of n minus 1 mod n must be 0. So I assume that all of you know. Yeah, Mahi, these questions can come in the exam. So I assume that all of you know what does mod mean. Mod is remainder function. इसका क्या मतलब है कि अगर मैं 7 को 3 से डिवाइड करूंगा तो रिमाइंडर 1 आ जाएगा. 7 mod 3 is 1. That is what this function means. So, according to the question, factorial n minus 1 is completely divisible by n, which means the remainder will be 0. So, I hope this is clear to all of you, right? The notation is clear. कैसे करेंगे इसको? We'll start taking numbers one by one, isn't it? So let's take. If n is equal to 2, I have here factorial 1 mod 2. Factorial 1 क्या होता है? 1. 1 को 2 से divide करो, remainder 1 आएगा. So we cannot count 2, right? 2 cannot be counted. If I take n as 3, 3 minus 1, factorial 2 mod 3, the value will be 2 here. यहाँ भी 0 नहीं है, तो 3 can also be not be counted. If I take n as 4, then I'll have factorial 3 mod 4. Factorial 3 is basically 6. 3 into 2 into 1, 6. 6 mod 4, if I solve, I'll get 2. Again, 4 can also be not counted. तो कौन सा काउंट होगा? कुछ पैटर्न मिल नहीं रहा हमें. Do you find a pattern here? Let's put n equal to 5 and let's see what happens. n minus 1 factorial 4 mod 5. Factorial 4 is 24. 24 mod 5, the answer is 4. Again, not possible. हमने 2 से 5 तक चेक कर लिया, किसी से भी नहीं हो रहा. चलो, let's now put n equal to 6. Then we have factorial 5 mod 6. And factorial 5 is basically 120. 120 6 से completely divisible है. 6 will be counted. So what exactly is happening over here? If you look at it, whenever n is prime, like 2, 3, or 5, it is not completely divisible. And if n is composite, like in 6 it was divisible, but in 4 it was not divisible. तो पैटर्न मिल रहा है क्या? इस बात को समझने के लिए हमें एक और बात समझनी पड़ेगी कि 6 में क्यों हो रहा था. See, factorial 5 is nothing but 1 into 2 into 3 into 4 into 5 and divided by 6. 6 was basically 2 into 3. So as we can see, that we have got a pair of 2 and 3 in factorial 5, that is why it is completely divisible, otherwise not. In case of 4, factorial 3 was 1 into 2 into 3, while 4 was 2 square. Here we needed 2 2's. We have only 1 2, that is not possible. So, if I take any kind of composite number, if I take 8, factorial 7 mod 8, it will be divisible. Why? Because 8 is 2 into 4. I'll get 2 into 4 here, because 7, factorial 7 is 1 into 2 into 3 into 4 into 5 into 6 into 7. I got 2 and 4, which makes 8. So, whenever we have a composite number, उससे एक कम के फैक्टोरियल में उसके फैक्टर्स तो आ ही जाएंगे, बट 4 में ऐसा नहीं हो रहा. सो वी कैन से दिस थिंग विल बी अप्लाइड टू ऑल द composite numbers except 4. Is that clear? Is that clear? By the way, this is what Wilson theorem means. So Wilson theorem says factorial of n minus 1 mod n is 0 if and only if n is composite except n equal to 4. So 4 is the only exception, and this theorem is known as Wilson's theorem. So those who studied in the class, they know it. Those who did not, now they know it. This is called as Wilson's theorem. Tanmay, exactly. Very good. So from 2 to 100, we have 99 numbers, out of which 25 are prime and 4 is an exception. 4 भी एक नंबर है, उसको भी माइनस कर दो यहाँ से. So all we have is 73, right? The answer is 73. यहाँ बोला गया है divisible, not divisible नहीं बोला गया है. So those who have marked 26, उनका आंसर wrong है. तन्मय, तुमने 74 लिखा, तुम छोटी सी गलती कर दी है तन्मय. पता है क्या, तुमने शायद ये पढ़ना भूल गए कि यहाँ 2 से शुरुआत है, 1 से नहीं है. ओके तन्मय, I hope you got it. Clear? Clear Tanmay and others? Okay, leave it. In how many ways can 120 be written as product of two numbers? This is the question. So here I want to show you a pattern. ये छोटा नंबर है पता है हमें, चलो 1 से तो होगा डिवाइड, हर नंबर होता है. 1 into 120 is the first pair. 2 into 60, we can do it orally, isn't it? Like, it's not a big deal to solve this question. The big deal will be when this number will be huge, isn't it? Okay, we have done that. So 1, 2, 3, 4, 5, 6, 7 and 8. Answer is 8. There are 8 ways. But can we create a shortcut because there can be huge numbers here, isn't it? What if someone asks you कि चलो बताओ, in how many ways can 3600 be written as product of two numbers? So if you keep on doing it, you will end up wasting a lot of time. So what needs to be done? By the way, I want you to see at one particular pattern that be it 1, be it 120, be it 2, be it 60, all of them are factors. All are factors of what? Of 120. So basically, if I can find the number of factors, then divide it by 2, that will be my answer. Yes or no? Would that be my answer? Of course, yes. चलो चेक करते हैं. तो 120 के हमारे पास कितने फैक्टर्स हैं? For that, we'll use the formula. Let's factorize it first of all. 2 cube into 3 into 5. So number of factors will be 3 plus 1 into 1 plus 1 into 1 plus 1, which will be 4 into 2 into 2. 16 factors are there. So 16 upon 16 factors हैं, तो कितने पेयर्स बनेंगे? 8 बनेंगे. सिंपल सी बात है. 16 लोग मिलके कितने पेयर बनाएंगे? 8 ही बनाएंगे. तो आंसर is 16 by 2, that is 8. Okay? So this thing is being followed. All right, is that clear? So for this kind of question, we need to find the number of factors, then divide by 2. But there can be a problem. वही क्वेश्चन है, मैंने 144 डाल दिया. Now see what the problem will be. 1 into 144, 2 into 72, 3 into 48, 4 into 4 3s are 12, 36, 5 6 से कटेगा, 6 into 24, 8 से भी कट जाएगा, 8 into 18, 9 से भी कटेगा, 9 into 16, what else? 10, 11, 12 से कटेगा, 12 into 12. So here I can see there are 1, 2, 3, 4, 5, 6, 7, 8 possibilities, but out of which in 7 possibilities we have, in 7 cases we have distinct factors. But in one case, this case, we have same factors. Is that right? ऐसा क्यों हुआ आखिर? Why did that happen? That happened because 144 is a perfect square. Do you understand it? Perfect square था, इसी कारण से इसका एक फैक्टर तो इसका स्क्वायर रूट ही हो गया. 12 को पेयर मिला, 12 का पेयर खुद 12 है. Are you getting it? Tell me in the comments. 12 का पेयर खुद 12 है. 12 into 12. तो अगर ये सवाल पूछा गया तो आंसर क्या होगा? आंसर विल बी 8. 8 different ways. But अगर उसने पूछ लिया in how many ways can this be written as product of two distinct natural numbers? Two distinct, then your answer will be 7. Is that clear? Understood? So we have to keep this in mind always. Right? Okay. If I try to look at the formula, number of factors upon 2, and what will happen? 144 is 2 to the power 4 into 3 square. Number of factors here are 4 plus 1 into 2 plus 1. So I got 5 into 3, 15 factors. 15 factor हैं, समझ में आ रहा है? 15 by 2 तुम कहीं नहीं पाओगे. You cannot divide this by 2. It will be 7.5. तो होगा क्या? If you divide this by 2, जो इंटीग्रल वैल्यू आएगी that will be distinct number of factors. 15 by 2 is 7.5. So 7 is the number of distinct ways and 0.5 आया उससे एक बढ़ा दो. 8 ways will be there in totality. So also, as you can see, here we got odd number of factors. But in previous case, we got even number of factors. Can I say, exactly Kunal, can I say that all the perfect squares have odd number of factors? Can I say that? Yes or no? Of course I can say that, because only in odd perfect squares we will get these powers as even. तो इनमें वन ऐड करते ही these two become odd. So all the perfect squares have odd number of factors, and reverse is also true. Reverse is, if a number has odd number of factors, it has to be definitely a perfect square. Clear? Any doubt there? I'm repeating. All perfect squares have odd number of factors, and if any number has odd number of factors, it will definitely be a perfect square. Cool. Having established that, let us try to solve a beautiful question. This question, I'm giving you 3 minutes for this. Try to solve it. Yeah, this is a challenging question. I have mentioned it as a mind bender. Kunal, Google interview? Apurva is okay, nice. Do you know how to solve? Of course, he knows it. Oh, he doesn't know it. Okay, I'll give you 1 minute more. Okay, so let me solve this. 100 lights displayed. Each bulb is turned on and off just by pressing its switch. They're all turned off at inception, like in the beginning, all were off. And then 100 traders arrive. The first trader comes in and presses the switch of each light bulb from 1 to 100. पहले वाले ने सबका सबका switch press कर दिया, सब कुछ on हो गया. Second trader comes in and presses switch of the second light bulb. Then the fourth, the sixth. So second वाला क्या कर रहा है? All the even numbers को कर रहा है ना? Second, fourth, sixth and eighth. Third वाला हर third को third, sixth इस तरह से कर रहा है. So basically, what is happening? If I say this is switch 1, switch 2, switch 3, switch 4, switch 5. I'm taking an example of, let's say, 10 switches in total. तो मुझे ये बताओ, पहले वाले को, पहले वाले स्विच को पहला बंदा छुएगा, ओके? वो सेकंड को भी छुएगा, थर्ड को भी, फोर्थ को भी, फिफ्थ को भी, सिक्स्थ को भी, सेवंथ, एट्थ, ninth and 10th. Okay, we know this. So tell me something. Initially, the switches were off. So moment he touches it, all become on. Yes or no? All become on. Then comes second one. Second one touches switch 2, switch 4. So basically, instead of writing 1, 2, I'll write on and off. That will make more sense. All right. See what exactly is happening here. Switch 1, the first trader, T1, trader 1 comes, trader 2, I'm taking, let's say, some examples over here. So, trader 1, he comes there and makes it on. So, everything is on now. Everything is on now, on, right? Second one comes, and he touches every second switch. So basically, first switch is not touched. So second iterator when comes, the switch one is on only. It doesn't change, but second one becomes off, right? Because he's touching every second switch. Is that clear, everyone? दूसरा चौथा छठा आठवां दसवां उसने छुआ मतलब switch किया and all became off, but the remaining one remained in on position only. Now what does that mean? Can I say if a switch is touched by odd number of people, it will be on. If it is touched by even number of people, it will be off. Yes or no? We can say that. I can say that, right? स्विच वन को सिर्फ एक बंदे ने छुआ है तो वो ऑन था, क्योंकि इनिशियली एवरीथिंग वाज ऑफ. तो अगर कोई बंदा किसी को एक बार छुएगा तो वो ऑन हो जाएगा, दो बार करेगा तो ऑफ हो जाएगा, तीन बार फिर से ऑन, चार बार फिर से ऑफ. सो इफ समथिंग इज टच्ड ऑड नंबर ऑफ टाइम्स इट विल रिमेन ऑन, and something is touched on even number of times, it will remain off. Is that right? That can be said. Perfect. तो एक बात बताओ मेरे को, पहले वाले को सिर्फ पहले ने छुआ, दूसरे को पहले और दूसरे ने, ठीक है? That is there. So first switch, second switch, third switch, fourth switch. First was touched by only one person, second by two people, third by two people, fourth by three people, fifth by two people, right? Sixth by four people. So can you see a pattern? The switches are touched by the people who happen to be the factors of the switches. So if I assume the switches to be the numbers and these to be the factors, तो मुझे वही चीज़ मिल रही है. तो यहाँ पे मुझे ऑड नंबर ऑफ फैक्टर मिले, यहाँ इवन फैक्टर मिले, यहाँ भी इवन मिले, यहाँ मेरे को ऑड मिले, यहाँ इवन मिले, यहाँ भी इवन मिले. So I am getting odd number of factors only on perfect squares, that is 1, 4. We discussed that, isn't it? पहले भी. So now we have established if a switch is turned by odd number of people, it will be on. क्वेश्चन में बोला गया है, क्वेश्चन में बोला गया है हाउ मेनी स्विच ऑन इन दी एंड, और ऑड नंबर ऑफ पीपल उसी स्विच को टच करेंगे जो स्विच परफेक्ट स्क्वायर हो. दैट इज 1, 4, 3 का स्क्वायर 9, 4 का स्क्वायर 16, 5 का स्क्वायर 25, 6 का 36, 7 का 49, 8 का 64, 9 का 81, 10 का 100. We have only 100 switches. So basically there will be 10 perfect squares, which means the answer is 10. Is that clear? So now you realize that just by a very simple thing which we discussed in previous slide, that is all perfect squares have odd number of factors, just by that we are able to do such a nice, complicated, difficult and beautiful question, isn't it? I hope you got it. ये सवाल नंबर सिस्टम का था, देखने में लग रहा था कि पता नहीं क्या है ये. चलो, perfect. All of you got it? Tell me this answer. Number of factors of 30,030. Okay, so let's solve this. 30,030. Let's factorize this first of all. सही किया मैंने factorize. Just tell me everyone if I did it correct. Right? Okay. So the powers are 1. We have 6 primes like this. So number of factors will be equal to 1 plus 1. How many times? 6 times. So 2 to the power 6, that is 64. We have 64 factors. And the product will be 30,030 to the power half of factors, that is 32. This will be the answer. I think all of you have done it. Very good. Cool. How many odd factors of 2880 are there? When we say odd factors, so what do we have to do? First of all, let us try to factorize it in prime factorized form. What do we get? How many parts of 2 will be there? Tell me. 5 powers, if I'm not wrong. Or 6 powers. 6 powers, right? See, now you might be thinking that how I'm doing it quickly. So what I do over here is, see, I will do it this way. We have 2880, right? I'll just break 288 and 10. 10 is nothing but 2 into 5. 288 is nothing but square of 144. It is square of, sorry, it is 2 into 144 and 144 is square of 12. And 12 in itself is 2 square into 3, 2 square into 3. So this is how I factorize things in my mind. How many 2's do we have? 1, 2, plus 2, 4, plus 2, 6. So basically we have 6 2's. Nice way, isn't it? Okay. How many 3's do we have? 1 and 2. 3 square. And how many 5's do we have? Only 1. So this is how I tend to factorize things quickly. You can also do the same. Okay. So how many odd factors? अच्छा odd निकालना है मतलब even चाहिए ही नहीं इसको. It doesn't require any even factors. How to do that? So basically we will ignore all the 2's. That's all. And that will help us. We'll take only these 2. So 2 plus 1 multiplied by 1 plus 1. That is 3 into 2. Answer is 6. That's it. Nothing else. Clear? Clear to everyone? Mandana, yes, right? पूर्वी ने शायद 1 2 बैग गायब किए बाकी गायब नहीं किए थे है ना पूर्वी? All right, पूर्वी. चलो, perfect. Let's do this one. How many factors of 3600 and multiples of 8? 3600. Let's try to factorize it. How am I going to do it? See, 3600, 100 is 10 square. कितने लोग ऐसे कर रहे हैं? कितना मज़ा आ रहा है ऐसे करने में? Mentally we can do it. This is 6 into 6, which is 2 into 3. See how beautiful this is. So how many 2's do we have? 1, 2, 3, 4. How many 3's do we have? 1, 2. How many 5's do we have? 1 and 2. Nice. Okay. How many factors of 3600 multiples of 8? What is 8? 8 is 2 cube. 8 is 2 cube. So if this can be written as, let's take 2 cube common outside. We're left with these things. Tell me something. Tell me something. If I take 2 cube common, which is 8 itself, so all of them will be factors of 8. All I have to do is to ignore this value, क्योंकि यहाँ हमने 8 को फिक्स कर लिया कि 8 तो है ही है, 8 तो है ही है, बाद में यहाँ जो भी आएगा हमारा आंसर होगा. So 1 plus 1 multiplied by 2 plus 1 multiplied by 2 plus 1. Is that clear? 2 into 3, 6 into 3 is 18 will be the correct answer. Understood? क्लियर? कुणाल 36 नहीं होगा, विल हैव 18. ओके कुणाल, I'm so sorry. I fixed 8, that means I have to ignore 8. Well, factorials. All of us know what factorials are. Factorial n is equal to 1 into 2 into 3 till n. Okay. Let's try to solve this question. The highest power of 3 that can divide factorial 20. For this, all you need to do is just divide 20 by 3. You get 6 point something. Take 6 only. Let's take the integral values, nothing else. Then divide 6 by 3, you get 2. Now you can't divide 2 by 3. So that is all. So answer is 6 plus 2, that is 8. This is successive division. तो किसी ने बोल दिया कि यहाँ पे 20 की जगह if it was factorial 100, then you would have done this way. 100 by 3, 33 point something, we take only 33. Alright? Then 33 by 3, we keep on dividing whatever we get here. 11 by 3, 3 point something, 3 by 3 is 1. Now we cannot further divide. Till the time we can divide, we'll keep on dividing. So answer is 33 plus 11. Okay, 44 plus 3, 47 plus 1 is 48. That is how we will be doing it. Perfect. This one, highest power 35, that can divide factorial 100. यहाँ पे कुछ लोग मैंने देखा क्या करते हैं, 100 को 35 से डिवाइड कर देंगे, बोलेंगे देखो 2 आ गया, ये हमारा आंसर है. But this is wrong. Why? The 35 is not prime. It is composed of 5 and 7. All right, 5 and 7. Now tell me something. अगर मैं 5 की वैल्यूज निकालूं, कितनी बार 5 आएगा फैक्टोरियल 100 में, आंसर आ जाएगा. 7 कितनी बार वो भी आ जाएगा. But tell me something. If I have both 5 and 7, to make a 35, I need a 5 and 7. और एक बात तो कंफर्म है कि 1 से 100 तक की गिनती में 5 ज़्यादा होंगे, 7 कम होंगे. तो आंसर वही होगा जितनी बार 7 आएंगे. इज दैट क्लियर? मान लो 5 आ गया 25 बार, 24 बार, और 7 आ गया 16 बार, तो वी कैन मेक ओनली 16 पेयर्स, इजंट इट? सो व्हेनेवर यू हैव समथिंग लाइक दिस, बाय लॉजिक यू कैन अंडरस्टैंड, रियलाइज दैट द वैल्यू विच कम्स लेस विल बी द आंसर. है ना? देखो, अगर मैं 5 निकालता हूँ, मुझे क्या मिलेगा? 20, then 20 by 5, I get 4. Overall 24. So there are 24 powers of 5, and for 7, 14 by 7 is 2. There are 16 powers of 2, of 7. तो अगर मैं 5 और 7 के पेयर बनाऊंगा, 16 बन पाएंगे, क्योंकि 8 जो 8 बार 5 है, उनको पेयर मिलेगा नहीं. So answer is 16. So you can directly calculate for 7 and get the answer. Let's do one more. Here 24. 24 is nothing but 2 cube into 3. Now we are not really sure. 3 2 से कम तो आएगा, लेकिन यहाँ 2 क्यूब है. क्या पता 2 क्यूब मिलके 3 से कम हो जाए. So here we need to calculate both for 2 and 3. Okay? There are different kind of values. And depending on the logical perspective, we'll be able to find out which one we have to calculate, which one we have to ignore. 50 plus 25 plus 12 plus 6 plus 3 plus 1, we have 97 times 2. And for 3, we calculated earlier also, 48 times 3. So there are 97 2's, but I need triplets of 2. So if there are 97 2's, how many triplets can I make? 3 into 32. I can make only 32 triplets. एक इसका 2 बचा रह जाएगा. 32 यहाँ, 48 यहाँ. So answer is 32. The least value will be the answer. Is that clear? With 97 2's, I can make only 32 triplets. और 48 यहाँ, 3 यहाँ पे 48 times है. So of course I'll be able to make only 32 such powers of 24. Right? These are some simple questions which can actually trick you into believing that 48 is the answer. But here the answer will be 32. One more. how many numbers less than 100 are co-prime to it? So whenever you have something like this, here the number is n, that is p to the power a, q to the power b, r to the power c, and so on. And en gives the value of the co-primes less than n. This will be equal to n times 1 minus 1 by p into 1 minus 1 by q into 1 minus 1 by r, and so on. So I think you can do it. 100 is 2 square into 5 square. So E100 will be equal to 100 into 1 minus 1 by 2 into 1 minus 1 by 5. So I get 40 as the answer. Clear? Ayush, which part? अच्छा 297 बार आ गया मेरे पास, 348 बार आ गया. मुझे चाहिए क्या? मुझे 24 की पावर्स. तो 24 जो है वो 2 क्यूब इंटू 3 से बना हुआ है. तो यहाँ पे अगर 297 बार है तो कितने ग्रुप ऑफ 3 आई कैन टेक हियर? या जागृति, आई एम एक्सप्लेनिंग दैट. I have 97 twos, so how many groups of 3 can be made out of 97 twos? 32 groups only, isn't it? If you divide 97 by 3, you will get 32 as the quotient, and 1 will be remaining. उस 1 को group मिलेगा ही नहीं. That is how I came to the conclusion that there will be 32 groups of 2 cube. Clear? So basically, this 32 groups of 2 cube and 48 groups of 3. So we need to combine 2 cube and 3. I can make a complete group of 2 cube and 3 only 32 times. That's how I got the answer. Is that clear now? Ayush, Purvi, Kunal, Jagriti. ठीक है, समझ में आ गया? सिंपल था. Okay. This is also clear. Very good. HCF or GCD. So whenever we have to find the HCF is basically highest common factor, GCD is greatest common divisor. So एक एग्जाम्पल लेते हैं, समझ सबको आ जाएगा. हमें जल्दी जल्दी रिपीट करना है. Sorry. So let's say I have numbers like 24 and one more like 36. I need to find the HCF as well as the LCM. So when we were young kids, Purvi, I did not use Chinese remainder theorem. I use Euler's, EULER. Chinese तो बाद में करेंगे for remainders, right? So we'll pick a prime which divides both of them. It is 2, 2 12 24, 2 18 36, 2 6 12, 2 9 18. Now we cannot pick anything which is common. If I pick 2, it will be dividing only 6 but not 9. If I pick 3 now, wait. We cannot pick 2, we can pick 3. 3 2s are 6, 3 3s are 9. Now we can't pick anything. 2 and then 3. So basically what happens, if I pick something common in both, all of it is a part of HCF, and whatever is common as well as uncommon is a part of LCM. Is that right? So I'll change the ink to make you understand. The HCF over here will be 2 into 2 into 3, that is 12, and the value of LCM will be 2 into 2 into 3 into 2 into 3, that is 72. Is that clear? Purvi, Euler's, you forgot the name? No problem. Euler करता ही यही है. क्या करता है Euler? किसी भी नंबर से कम कितने co-prime होंगे, that is what it counts. The number of co-primes less than n is counted by En. That's it. Nothing else. अभी remainders में use नहीं कर रहे हैं. That's the theorem. The same theorem can be used in remainders, which will be coming, later on. Is this clear? So all I am saying is HCF will be a combination of all the common factors, and LCM will be a combination of all the common as well as uncommon factors. Clear? Let's try to solve a few questions. What is the minimum number of cubes that can be cut from a cuboid of side 14 into 21 into 35? Okay. In order to minimize the number of cubes that can be cut, we need to maximize the volume of cubes. Yes or no? Isn't it? So 14, 21 and 35 का HCF क्या होगा? If I take 7 here, now I cannot take anything common, so HCF is 7. That means if I cut a cube of 7 into 7 into 7 dimension, that will be the largest cube that can be cut. Yes or no? और कम से कम क्या होगा? 1 into 1 into 1. If the sides are integral, this will be smallest cube. Tell me something. If I divide this whole 14 into 21 into 35, this is volume, isn't it? Length into breadth into height. अगर मैं इसको divide कर दूंगा smallest वाले से, I'll get the same value. और इससे largest से कर दूंगा, then I'll get a different value. But in both the cases, I'll be able to get the number of cubes. Here I get 30 cubes. Here I'll get 14 into 21 35. तो मुझे अगर क्यूब्स मिनिमाइज करने हैं तो मुझे उसका वॉल्यूम मैक्सिमाइज करना पड़ेगा. दैट इज वाई विल सेलेक्ट दिस एंड रिजेक्ट दिस, सेलेक्ट दिस एंड रिजेक्ट दिस. इफ दे आस्क मैक्सिमम नंबर ऑफ क्यूब्स तो आप ये ले लोगे. इज दैट क्लियर? इट्स कॉमन सेंस, इजंट इट? अगर मुझे किसी से कम करना है डिवाइड करके तो मैं डिनोमिनेटर को बड़ा कर दूंगा. Yes, Ayush, that's a nice question. If you get a feeling of dividing something, okay, when they say when you divide something, then it will be HCF. And if something, okay, let me put it this way. Like in this question, we have to HCF is factor and LCM is multiple. So if we get a feeling of can divide, it will be HCF, and if it is can be divided, it will be LCM. Ayush, is that clear? So when I say can divide, जहाँ feeling आ रही है कि we can divide, we'll use HCF, and the feeling is it can be divided, we'll use LCM in those cases. So here we can divide the larger cube into smaller cubes. That is why we are using HCF. ठीक है? Cool. All right. चलो अब ये करते हैं. When this and this are divided by the greatest number x, the remainder in each case is y. What is the value of x minus y? जब भी ऐसे सवाल हमारे सामने आ जाएं तो एक बात बताता हूँ मैं. 1062, 1134. So there is one more way of finding the HCF, and that is when you get three numbers like this, just find their differences. Okay? Just find their differences. यहाँ डिफरेंस क्या आ जाएगा? 1062, 1134 में कितना आ जाएगा? Tell me. 72. यहाँ कितना जाएगा? 48, right? So whenever you have something like this, there are a lot of numbers in series, and if you do not want to do it by successive division, you can find the successive differences and then find the HCF of these differences. That will be our answer. कितना आएगा इसका HCF? 48 and 72. 24 से कट रहे हैं दोनों ना. 24 2s are 48. 24 is the answer. 24 is the HCF. So basically greatest number पूछ रहा था वो. Greatest number divide करने पे ये आ रहा है. Right? So that greatest number is 24, and now we can divide any of these by 24 and then find the value of the remainder that happens to be y. Okay? So value of x over here is 24, and value of y we can find by dividing any of these numbers by 24. Let's divide 1062. 24 4s are 96. 24 4s are 96 again. 6 is the remainder. That means y is equal to 6. To find the value of x minus y, 24 minus 6, the answer is 18. Is that clear, everyone? Is that clear? So just told you a method when we have a lot of numbers, we can just find the differences and then their HCF and we'll get the answer. Cool? So we have done HCF and LCM, we have done factors and multiples, we have done prime numbers, composite numbers, a lot of things we have done. And now we have remainders left. So tell me, there are two ways. Either I take up remainders today itself, it will take 1.5 hours more. It's a major part of numbers, or we can have one more marathon number 2, in which we can do all the remainders from starting to ending. Purvi, I'll come to that. Why finding a difference? There has to be a logic. Ayush, you can take 1 and 3, 4 also. It won't really change the answer. See, why I'm finding the differences, I'll tell you that, and also tell me whether you want me to continue for remainders or we can take one more marathon like this. So, factors, multiples, HCF, LCM, prime numbers have been done, and in the next we can have remainders. चलो ये क्यों हो रहा है देखते हैं. See, let me assume a number n1 and this can be written as d1 q1 plus r1. Now you'll ask, what is this? Right? Let the number be d1. Where it's coming from? There's a simple thing, capital D is equal to small d into q plus r, where capital D is the dividend. All of you remember that? Small d is the divisor, q is the quotient, right? And r is the remainder. You remember that? For example, 24 is equal to 5 into 4 plus 4. So here 24 is the dividend, 5 is the divisor, 4 is the quotient, and 4 is the remainder. Okay, we'll have marathon 2. Is this clear? So I took two numbers like this, d1, let me take d2 also, d2 q2 plus r2. Okay? This is clear. Now this question says, the remainder is same. The remainder is same. So when the remainder is same, and at the very same time, see what I'm going to do here. चलो इसको छोड़ देते हैं. Now applying the above conditions. What are the conditions? The conditions are that it is getting divided by greatest number and remainder also same. D1, D2 are same, R1, R2 are same. So I can say that D1 is equal to dq1 plus r and d2 is equal to dq2 plus r, right? Those are the conditions. Yes or no? Right? Can I say that? Is it understandable? इस बात को मैंने ऐसा लिखा, फिर मैंने अप्लाई की कंडीशन कौन सी? ऊपर वाली. यहाँ बोल रहा है डिवाइड भी सेम नंबर कर रहा है तीनों लोगों को, यहाँ मैंने 2 लिए और रिमाइंडर भी सेम ही आ रहा है. सो I have equated D, divisor and remainders. Now if I find a difference, D2 minus D1, what do I get? See, you'll be surprised to know this. R and R get cancelled, small d is common, and we get Q2 minus Q1. I get Q2 minus Q1. ओके तो जब मैंने माइनस किया ना, पता क्या हुआ? रिमाइंडर वाली बात ही गायब हो गई. And that is the reason I subtracted. Now it makes sense. Now you have got the mathematical explanation that why it was happening. So while subtracting, the remainders were getting cancelled. And that's what we wanted. That is how we calculate the value of x. Is that cool? Purvi ने अच्छा सवाल पूछा था. And I think now she's satisfied with the answer. And everyone also. है ना? So whenever you have something like this, you have 2 or 3 or more numbers, just find the differences and all the remainders will be cancelled out. All you'll be left with is the highest common factor. So having said that, I'll take your leave. We'll meet again, marathon 2. I'll tell the date. It's not tomorrow because tomorrow I have different class. But after that, I can have a marathon. I'll ask Mr. Yogesh to, Yogesh sir to, send the message out to you guys. Good night, everyone, and tell me how do you like the session? How do you enjoyed it? What all things you learned? Was it a revision which was worth the wait? Thanks.